These are the 5 most ambitious megaprojects humanity has ever seriously proposed. If even one of them becomes reality, it could push our civilization into an entirely new era. First, the orbital ring. Imagine placing a gigantic ring around Earth, stretching all the way around the planet above the equator. Unlike a space elevator that relies on a single cable, the orbital ring would be a complete transportation network encircling Earth. Inside the ring, massive structures would move at incredible speeds, while magnetic levitation technology keeps platforms stable. From those platforms, long tethers would extend down toward the surface. Instead of launching expensive rockets and burning tons of fuel, people and cargo could simply ride elevator-like vehicles from the ground to the ring, then transfer directly into space. This would be the equivalent of building the world's first permanent highway between Earth and orbit. Space travel could become dramatically cheaper, safer, and more routine. If humanity ever succeeds in constructing the orbital ring, it may be remembered as the moment when Earth stopped being our limit and became just the starting point. The orbital ring wouldn't just make space travel easier, it would turn going to space into an everyday commute. What makes this idea so revolutionary is that it doesn't rely entirely on super strong materials. Instead, it relies on motion. Think about spinning a bucket of water over your head. Even upside down, the water doesn't fall out because it's moving so fast. The orbital ring works on a similar principle. High-speed structures racing around Earth provide the support, while outer platforms use that energy to remain stable. In other words, it's not a giant ladder to space. It's a colossal machine constantly circling the planet. But that's also where the challenge begins. If something goes wrong, it's not like an elevator breaking down. You're talking about a megastructure thousands of kilometers long, orbiting above cities, oceans, flight paths, and satellites. The materials, maintenance, energy requirements, orbital control systems, and emergency safeguards are far beyond anything humanity can easily manage today. Yet if the orbital ring is ever built, it won't simply send people into space. It will transform Earth's surrounding space into infrastructure itself, turning the frontier of space into an extension of civilization. What if Earth simply runs out of room? Most people would say the answer is Mars, but in the 1970s, physicist and engineer Gerard K. ONeill proposed something far more ambitious. Don't search for another Earth, build one in space. This idea became known as the ONeill cylinder. The concept is surprisingly simple, yet almost unbelievable. Imagine a gigantic cylinder floating in space, slowly spinning. People wouldn't live in the center. Instead, they would live on the inside surface of the cylinder itself. Stand inside, and beneath your feet would be land. In the distance, you'd see cities, rivers, forests, and vast farmland stretching across the curved interior world. As the cylinder rotates, centrifugal force pushes everything outward, creating artificial gravity. Water flows downward, trees grow normally, and children can run and play just as they do on Earth. At first glance, it sounds like an oversized space station, but it's something much bigger. A space station is a place to visit. An ONeill cylinder is a place to live, a fully functioning world built by human hands. If humanity ever constructs one, we won't just be exploring space anymore. We'll be creating new worlds within it. Today's space stations are essentially laboratories assembled from a handful of connected modules. The ONeill cylinder is something entirely different, a complete world. Inside, there would be day and night, weather systems, farms, rivers, forests, and entire cities. It wouldn't just support life, it would recreate an entire ecosystem in space. The strangest part would be the sky, because people live on the inner surface of the cylinder. Looking up wouldn't reveal an endless blue sky. Instead, you might see another city hanging far above you on the opposite side of the cylinder. The landscape would curve upward in the distance, eventually disappearing over your head. For the first time, you'd realize that even a horizon can be artificial. That's what makes this concept so fascinating. Instead of trying to transform Mars into Earth, why not build a world from scratch? The size can be chosen by design. The gravity can be adjusted. The day-night cycle can be controlled. Even the direction and intensity of sunlight can be engineered. But the more beautiful the vision becomes, the more terrifying the challenges appear. A structure this enormous cannot realistically be built from materials launched from Earth. Most proposals suggest mining the moon or nearby asteroids for raw resources. Before humanity can build a new world in space, it may first need to create an entire space-based industrial civilization. The ONeill cylinder isn't just a space habitat. It's humanity's attempt to become a species that builds planets instead of merely living on them. Before humanity can build an ONeill cylinder, it would need technologies we barely possess today: massive lunar mining, asteroid industries, orbital factories, artificial ecosystems, and protection from cosmic radiation. That's why the ONeill cylinder asks a deeper question. If the universe doesn't offer humanity a second Earth, can we build one ourselves? It's not about escaping our planet. It's about recreating the tiny, fragile layer of conditions that make life possible. And now, the third megaproject, supervolcano geothermal cooling. The idea is astonishing. Beneath a supervolcano lies a gigantic magma chamber containing an unimaginable amount of heat. Instead of fearing that energy, humanity could try to harness it, drilling deep underground to generate enormous amounts of geothermal power while gradually cooling the magma system itself. In theory, we wouldn't just be producing clean energy, we'd be attempting to tame one of the most powerful natural forces on Earth. Imagine drilling a network of wells several kilometers deep around the edge of a supervolcano's magma chamber. Cold water is pumped underground into extremely hot rock layers, then returned to the surface as superheated water and steam, generating enormous amounts of electricity. In a sense, humanity wouldn't be building a power plant on the surface. We would be turning an entire supervolcano into a giant geothermal generator hidden beneath the Earth. But the most fascinating part isn't the energy. As these wells continuously extract heat, they could slowly cool the outer regions of the magma chamber. Given enough time and enough energy removed, the pressure and temperature driving a future eruption might gradually decrease. That's what makes this concept so extraordinary. Instead of waiting for a supervolcano to erupt and then dealing with the disaster, humanity would try to reduce the threat before it happens. Picture a massive geological time bomb buried beneath the planet. Rather than running away from it, we're carefully drilling into the surrounding rock and slowly diffusing it, while harvesting clean energy at the same time. If successful, humanity wouldn't just gain one of the largest power sources in history. We might also reduce the risk of a civilization-scale catastrophe before it ever begins. The idea of space-based solar power is surprisingly straightforward, but the implications are enormous. On Earth, solar energy is limited by day and night cycles, weather conditions, clouds, and atmospheric interference. Even large solar farms lose efficiency because sunlight is never constant. Now imagine moving those solar panels into space. In orbit, there is no night, no clouds, no rain or snow, no atmosphere filtering or weakening the sun's energy. A space-based solar power station could continuously collect pure, uninterrupted sunlight 24 hours a day. These gigantic orbital arrays would convert solar energy into electricity, then transmit it back to Earth using microwaves or laser beams directed at ground-based receiving stations. In effect, humanity would be relocating power generation to the most efficient place possible, directly in sunlight, above all atmospheric limits. But the truly radical part is not just putting solar panels in space. It's the idea of turning Earth's orbit into a permanent, continuous energy grid, an infrastructure layer above the planet that never sleeps. Instead of space being just for satellites or research stations, it could become a vast field of power plants orbiting Earth. If realized, space would no longer be empty. It would become one of the most important energy production zones in human civilization. They would spread across Earth's orbit like artificial suns, vast space-based solar farms that never set. On the ground, enormous receiving stations would collect the energy beamed down from orbit and convert it into usable electricity for cities and industries. But this isn't just about moving solar panels into space. It's about overcoming everything that holds current systems back: launch costs, orbital construction, long-term maintenance, energy transmission, and the massive question of trust in such a powerful technology. Because once energy can be sent from orbit, it changes everything. Space is no longer just a place for satellites or exploration. It becomes part of Earth's power infrastructure. And then comes the fifth megaproject, the lunar mass driver. Picture a gigantic electromagnetic launcher built on the moon. Instead of weapons, it fires raw lunar materials, metals, ice, and construction components into space. The reason is simple. Earth is expensive to launch from, but the moon isn't. With far weaker gravity and no atmosphere, it becomes the perfect launch platform. If it works, the moon stops being a silent rock in the sky and becomes humanity's first true industrial supply base for building a civilization beyond Earth. To reach space, rockets from Earth must burn enormous amounts of fuel just to escape gravity. But the moon is different. Its gravity is only about 1/6 of Earth's, and it has almost no atmosphere. That changes everything. Instead of using rockets, humanity could build a lunar mass driver, a giant electromagnetic track on the moon's surface. Once built, it could accelerate materials along the track and launch them directly into space. Think of Earth's launch system as climbing out of a deep gravity well. The moon, on the other hand, is like standing near the rim and simply throwing things outward. That's the real value of the lunar mass driver. If humanity ever wants to build megastructures like ONeill cylinders, orbital rings, or large space habitats, we need massive amounts of material in space. Launching everything from Earth is too expensive. But if the moon becomes a supply base, providing metals, oxygen, silicon, and construction resources, and a mass driver continuously sends them into orbit, then large-scale space construction finally becomes realistic. At that point, the moon stops being just a destination. It becomes the industrial backbone of human civilization in space, a vast mining and construction hub orbiting our world. But even that introduces a critical problem. Those high-speed lunar materials must be carefully controlled. If not, they could become dangerous debris orbiting Earth. That's why the lunar mass driver isn't just about launching materials. It's about transforming the moon into the logistics hub of a space-based civilization. At that point, humanity would truly begin reshaping the Earth-Moon system into a single industrial network. Not just a planet and its satellite, but a connected manufacturing and construction machine operating across space. From materials and energy to orbital structures and living habitats, everything would start linking together. Space travel would shift from launching rockets to moving through infrastructure. Even interplanetary journeys could eventually feel like stepping between connected stations in a vast system. And yes, what once looked like science fiction would become engineering reality. Because history shows a pattern. Every technology that once felt impossible eventually became normal. Flight, spaceflight, global communication, all were once fantasies. So the real question is, which of these megastructures comes first? An orbital ring, a lunar industry, or a space-based power grid? If humanity truly begins building any one of them, it won't just change space, it will change what it means to be a civilization. I'm Old Mark. See you in the next universe.